Welcome back to another video. So today we are going back to basics and doing some dietary calculations. So we have the conversion table. You should memorize this, know it off by heart so you know exactly how to move between grams and kilojoules as shown, and then just get a laser. So kilograms to kilojoules and then kilocalories to kilojoules, because in South Africa most of the time we use kilojoules, but we can also use kilocalories. But yeah, understanding and knowing the conversions by memory helps with all the calculations. So let's get started on how to move between the two. So it's basic maths, I want to say, just to refresh your memory, and then we will go into calculating enteral feeds. So say for example you want to convert 20 grams of, say, carbohydrates to kilojoules. So how do we do this? You simply say 20 grams multiplied by 17, because 1 gram of carbs is equal to 17 kilojoules. Okay, so if we do that on my calculator, I get 340 kilojoules for 20 grams of carbs. Okay, so it's as simple as that. If you want to move backwards, so from kilojoules to, basically from kilojoules, we'll use that arrow, from kilojoules to grams, you simply divide. So 340 divided by 17, which will give us then 20, obviously. Okay, so that's the simple conversion. So the carbohydrates and the protein is the same. Okay, so let's convert fat. So we're going to say 40 grams of fat. We want to convert that to kilojoules, and then you just simply go 40 grams multiplied by 38 kilojoules, because 1 gram of fat is equal to 38 kilojoules. And we also see from this that fat is really energy dense. Okay, and that gives us 1520 kilojoules. So that's basically how we convert backwards and forwards from grams to kilojoules. So it's the same thing with kilocalories to kilojoules. Okay, 1 kilocalorie is equal to 4.2 kilojoules. So for example, say you have 100 kilocalories, you simply then multiply it by 4.2 to get to 420 kilojoules. Okay, if you want to convert it from kilojoules to kilocalories, just divide by 4.2, and then that will give you 100 kilocalories. Same with this. So you want to convert it back to grams, simply just divide by 38 to then give you 40 grams. Okay, so say we have a patient and the patient weighs 70 kilograms, and you are told that the patient needs to be fed enterally. So how do you go about doing the calculations? So let's start from here. What am I doing? Okay, we've got the requirements over on the left side. So I've just come up with some requirements for energy, protein, carbohydrates, fats, and fluids. So I've calculated these requirements, and they're the requirements per day, okay, that the patient needs. Then I've given you a hypothetical feed A with the energy, protein, carbs, fats, and fluids. And these values are per 100 ml. Okay, so that's why by the fluid I said per 100 ml. So for example, there is 7 grams of protein per 100 ml of this feed. There is 630 kilojoules per 100 ml feed. If you do your calculations, you will notice that this is 1.5 kcal per mol feed. So 1.5 kcal per mol. It is a high energy feed. How did I get that? So I simply just took 630 divided by 4.2. That gave me 150 kcal, and then if you divide it by 100, you get 1.5 kcal per mole. This is 150 kilocalories in 100 moles. Okay, so we know that this is a high energy feed. Okay, now how do you go about calculating? Let me get my laser pointer. How do you go about calculating the total amount needed per day from this feed that you've now decided to use or chosen? Okay, let's just say you chose this feed. How do you do the calculations? So we normally use protein to get the factor, which then is used to multiply all of these figures to get the total amount needed. But you can use energy if you need to use energy, or if you need to use, say, the fluids, if the patient is fluid restricted, as the basis for your calculations. But I normally just go with protein like 95% of the time. Or, yeah, like I'm going to say 99% of the time. But okay, so let's go with protein. You simply take your requirements, which is 91 grams. The values I've given in brackets is the percentage of total energy. So we have 19% of protein coming from the total energy. We have 54% of carbohydrates coming from the total energy, 27% of fat coming from the total energy. In your amount needed, you also need to calculate that. Same with feed A, the amounts of total energy that each macronutrient contributes towards the energy is given in brackets. Okay, so we can, if you compare these values to these values, you can see that the percentages almost is quite similar. Okay, so let's do the calculation anyway. So we have 91 grams from our requirements, and then we simply divide that by the protein in feed A per 100 moles. Make sure that you use the 100 mole value. It's going to make your calculation so much easier. So you get a value of 13. So 13 is the factor. Okay, so now you take 13, I'm going to just write it out here, and you multiply it by all macros and fluid. Okay, to get your total amount of fluid at the end. You need to calculate fluid so that you know how much or what volume of feed to use for your patient. Okay, and at what feeding rate. So let's do this. So we say 13, we're now calculating the energy. We simply just say 13 multiplied by 7938, which gives us, sorry, my mistake, 13 multiplied by 630 gives us 8190 kilojoules. So that's going to be your energy over there, 8190. I'm not going to write the SI units because the space is quite limited, but you get the idea. Okay, maybe I can just squeeze it in. There we go. Okay, to get the percentage of requirements met, you simply take this figure divided by your requirements. So that's, let's change the pen, 7938, which gives us 103%. You can round up, so we're going to do 103. Just erase that. Okay. Okay, you get that, right? So 103%. The percentage of requirements met should be, I have space, should be within the 90 to 110% range. Okay, sometimes it might go above, sometimes it might not meet it. So make sure you're able to motivate for that, or if you're able to use a different feed, then please use a different feed. Or if you're able to tweak the calculations, then please do so, because we'd like to ideally stay within the required range. Okay. So now for protein, because you used a factor of 13, you know you're going to use, or you're going to meet your protein 100%. Whichever macro you use for your factor is the macro that you're going to meet 100%. So if I take 13 and I multiply it by the 7 grams, I'm going to get 91 grams. Okay, there's like no doubt about that. Okay, so let's add in the 91 grams, and that's obviously 100%. Okay, then for carbs, you do the same. So 13 factor multiplied by 19 grams. I'm trying to use different colors. Okay, there we go. That's going to be 247 grams. And then again, you simply divide by 252 to get your percentage contribution, percentage of total requirements. So 247 divided by 252, which gives us 98%. There we go, 98%. So we just fill that in, 247 grams, 98%. Okay. And then in fact you do the same. So 13 multiplied by 5 grams, that is 65 grams. And then divide by 56, which is 116%. Okay, so here we notice that the fat is a little bit over our 90 to 110% range, but it's not that high, so it might still be acceptable. Obviously, make sure that you monitor your patient's condition and their biochemistry, obviously, as well as the tolerance. So we have 65 and we have 116%. So remember, sometimes it's not going to fall within the range. Ideally, we want it to be within the range. But if it's not, make sure that you monitor your patient's condition and whether they're tolerating the feed and the biochemistry and all of the other clinical signs, etc. If you have a different feed, use that feed, okay? Because, yeah, there's always a way. So, I mean, for example, I could tweak the protein or tweak the calculations here and there, but you can play around with it to make it fit within the 90 to 110% range, but this is just for illustration purposes, so yeah. And then fluids, we are just going to say 13 multiplied by 100 moles, which is gonna be 1,300 moles. Okay, so that's the total amount of feed that we need to use. This is excluding the flush, okay? So that's the maximum fluids for our patient, okay? This is what we need from the feed. So from here, we now calculate the feeding rate. Okay, so you can, we normally feed 3 hourly, so that's 8 feeds per day. Okay, so that's what we're going to be using, or you can be feeding hourly, depending on your patient's condition. But say for this patient, we feed 3 hourly. Okay, so you simply divide 1,300 moles divided by 8, meaning the patient's going to get 8 feeds in a day and is going to be fed every 3 hours. Okay, so we are calculating how much they are going to be fed every 3 hours. Okay, so you simply take that amount divided by 8, you get 162.5 moles. I always like to round up to 163 moles. Okay, so this is ideal if you have a kangaroo pump or an enteral feeding pump where you can use the settings accordingly and set your volume of feed, okay, at this rate. If you are in a resource limited setting where there's no feeding pumps and nursing staff have to use do it manually, basically, you can round it off to 165 just for ease of feeding, okay. But yeah, or 160. You can either do 160 or 165. Let's say we want to meet our protein, maybe say at 95% and not 100%. So what would we do? You simply just go like this. So you say, in order for the fat to meet within the requirements, okay? So instead of meeting 100% of protein, we're now doing 95%. So you just go, you look at how much is 95% of that requirements is. It's 86.45. We're just going to do 86 grams. So you simply say then 86 grams divided by your feed, which is 7 grams. So you go 7 grams and your new factor would be 12.3. So let's go 12 then. Okay, is your new factor. If you then multiply all your macros out from your feed A as well as your energy and your fluids, let's see what that gives us. Okay, so I'm gonna use a new page. Okay, so let's go energy, protein, carbs, fats, and fluids. Fluids, we know it's going to be 1,200 moles. Let's calculate the energy. So we simply say 630 multiplied by 12, 7,560. Okay, because there's 630, protein is 7 grams multiplied by 12. Okay, we know what's that already. It's 84. Okay, I think the values changed a little bit because of our rounding, but that's fine. And then carbs is 12 multiplied by 19, and then fat is 5. And then I should actually do this all together, but that's fine. And that's 60. Okay, so you can already see the fat is looking a bit better. It's no more 65. Let's just calculate. Okay, so now I'm just calculating the percentage of total requirements because I did not do it when I was calculating the feed. So just quickly do that. So this is 95%. That is 92%. That is 252. 90%, and that is 107%. So we can see that this is the one that we want to use because it's within the 90 to 110% range. So you can always tweak your requirements. So yes, we want to ideally meet 100% of protein requirements, but if that's not possible, then we tweak the numbers a little bit, say remember this needs to fall within 90 to 110% range. You can either use 90% or 95% or whatever, just so that we bring down the fat amount. Okay, so that's our final feed calculation, and that's the one that we're going to go for. So now we're just doing the feeding rate. So again, we just divide that by 8 to get a 3-hourly rate, and that gives me 150 moles 3-hourly. So this is a nice number to work with. And then we want to flush in between so that the enteral tube is cleared, or the nasogastric tube is clear. Okay, so that's the total amount from feed. You take your fluid, so you can either do maybe the lower end of it, because remember your patient might be getting IV fluids, so take that into account as well when you're doing your calculations. Say, okay, I'm going to take the lower amount and I'm going to allow for other fluids from IV. So we simply subtract that by 1200, which is the feed, to calculate the flush. So that's 900 moles of flush that is used in between feeds. Divide by 8, we get 112.5 moles. You can either round up to 113 moles, or you can round down to 110 moles for ease if you don't have the pump. Okay, but ideally, yeah, you want to be as close as possible to your calculations. So we're going to feed, say, at 150 moles 3-hourly. That's the feed, and the flush is going to be 110 moles 3-hourly, or 150 moles 3-hourly, and flush is going to be 113 moles 3-hourly. So that's how you do your enteral calculations. But there are many different ways of doing it. You can start with fluids. Okay, you can start with any figure basically. Obviously it needs to be justified, but we normally start with, let me just write this down. So we start with generally protein or energy or fluids. So these are the main ones that we normally work with or work around with. Okay, so another practical thing to do, what's very important to do, is to know how many bags of feed you'll need in a day. Okay, so the total amount of feed you need, my spelling, let's just do that. Total feed you need in a day is 1200 moles. Okay, so say your one bag of feed is equal to 500 moles. Okay, so you're simply then just going to divide the total feed by 500 to get the amount of bags you need in a day. Okay, simple maths. You can just say it's like 3 bags if you look at it there. So if we just calculate it for the sake of calculating, it is 2.4 bags per day. But obviously you're not going to get a 0.4 bag, so obviously, or like half a bag or whatever. So you just round up to say 3 bags per day to make sure that your patient has enough feed for that day.